Okay. We'll just check whether everything's on. And open up chat and that sort of stuff. Yeah. Alright, 1 second. Okay, so continue. Is this better? Let's see. I'm reluctant to change the gain on the mic without really being able to test it properly. So. Okay. Okay, so if we go to spaCy transforms, layers, transform model, attention mask. Right, so the word piece batch in here, go to classes, word piece batch. All right. Alright, glad I made some improvement at least. Yeah, so looking through the data classes that I have here already, I shouldn't really get lost in the weeds so much on this, but yeah, these little incompatibilities with transformers and these like small differences in you know, how things align and how things mask out and stuff can be pretty tricky, and so I'm nervous about ending up introducing these things. I guess I can always have notes for it. So yeah, where do we actually calculate the attention mask? Yeah, okay, so then we go from batch encoding, that's where we do that. From batch encoding. Okay. So that's, so we get that from, yeah, okay. So that kind of comes to us already. So we've got our IDs here, and now we want cool. All right, so that took care of that that error. Now, okay, so here we've got our spaCy IDs. So I think what we want to do here is tell it not to return the tensors, and then if we make the tensors ourselves, then oh wait, no. So the question is, where do we get the various? Yeah, so we've got print IDs. Input IDs, attention mask, token type IDs. How do we tell it to return us the lengths? Okay. So let's see whether that's what we want. It could be. So first of all, let's see what it returns us when we don't have. Let's see. What do we get when we don't tell it to do that? So that's the input IDs there, token type IDs, attention mask. So that's nested like that. Then we want transformer, and then what happens if we go return length? Yeah, so this is a little bit unfortunate. So the length there, this is the length of the whole sequence. What we want to know is how many word pieces this aligns to. I think let's try to the character offsets, return offsets mapping. That format is not obvious to me. I thought it would be a start and an end. That can't be right. Let's take another look at the docs. Whether or not to return the car start, car end of each token. I mean, that cannot be the data that we just saw. You know, how can it be that the first token is from span 0 to 0, then the second one's from 0 to 8, etc.? That doesn't make any sense. Raises mutations, I guess. Let's see, bird word piece. Return offset mapping. Okay, so it doesn't know about that. Right. So tokenization, utils, I guess. Well, these are all right. Let's look here. Return offsets. Right. Tokenization utils base. Batch and code plus. Yeah. Okay. Right, so it's the base class, which we don't want. We want the dirt one. Okay, so there's nothing interesting here. Let's try Rockbird. All right, let me switch tactics a little bit. I've been avoiding using coding tools a little bit for this. I found it with the transformers library because the API has changed a fair bit over time. It's often not that accurate. But all right, we'll try this. So let's see. All right. I should also log into my Claude Code account and all of that stuff. Yeah, so I was hoping to avoid this strategy of having to make all of these calls to the word pizza. Each sentence is encoding.word ID gives a list. Each element in this list corresponds to a word piece. The value of the index of the original token that the word piece belongs to, or none, if it's a special token like. Okay. So there's word IDs. Okay. Alright, so let's. I've got tokenizer from pre-trained. Is this just lies? Let's take a look. Alright. So. Okay. So this looks like the sort of thing that we want. So it's word IDs. Let's look at that. Okay, so we've got our spaCy IDs. Oh, okay, it's a method. Okay, that's much more promising. So what do we have here? So let's see. Yeah, so we take the batch index. So for range texts, print. All right, so that makes a little sense. Now let's update this to, so we don't need this offset mapping, and I still don't actually understand what that is. It should be this. And then, let's see. We've got texts. Alright. A little too tight. So hopefully that gets split up into multiple. Yeah, exactly. So this, lecithin is being mapped to two tokens, which is just what we want. All right. So that's good. Alright, so we want to keep this structure around, this encoding structure, because it has the alignment stuff that we're interested in. Yeah, so I use LLMs a fair bit for coding. I think I'm not the best at using them still. I'm trying to always get better, and so some of the usage that I do at the moment, I think probably I could actually do it a little bit faster without it, and you end up in these kind of busy loops. But it's definitely the path that I see to more long-term productivity. So I want to keep getting better at it. Mostly, it's just a tool like any other, and I find it good for tasks which are either at sort of two ends of a spectrum. Ones which I understand especially well, and I know sort of exactly how to describe what should be done and how to review what should be done. Then, those are pretty strict time savings most of the time. Then on the other side, things which are more exploratory, when I'm working with technologies I don't know very well, it's helpful there. And there's a lot of stuff which is just very knowledge intensive. So if you're working with like cloud technologies and things, it's very helpful to make sure that you're using the right, the right thing, or the options for like what you could be using and stuff. Those are things which I've found it quite helpful for that stuff as well. Okay, so right. So out of the word piecer, we definitely get the sort of thing that we want. So let's move back up one level of the stack here and think through what we were trying to do. So if we go to our tests, we were trying to get this working. So we want this make transformer. Let's go make Bert. Okay, and then what else? Okay. And now I think it's pretty clear that we're going to want yeah, so let's see. We want let's make this stuff return even better. Yeah. Okay, so if we go now right. So this we wanted to do, to have organizer transformer. And we want okay, so how do I do that part? So yeah, blah blah blah. This is quite slow. I should log in somewhere else. Ah, okay, yeah. So it's just the attribute assignment. Yeah, okay. Now does it matter if it's like that or like that? Super. All right. Okay, we don't have to do anything like that. Yeah, cool. So it just walks it over. Cool. Yeah. So now we go IDs, then okay, so now we go get IDs. This is where we want So in docs, batch. Now, we're going to have a misalignment in. Alright, so because we're filtering out these space tokens, we're not going to match when we have our word IDs. So let's remove that for now and come back to that. Okay, so here's our texts, and we want this. So return tokenizer. Yeah. And we want texts. Cool. Alright. So it's that. And this returns this encoding object. So or batch encoding or something like that. So what are you? Okay. Transformers, okay. Cool. So that's that. Then we need, so that's the activations, and then we need to format the output. So okay, so now let's just go So I'm sort of imagining that there'll be some, well, maybe this is silly, I'll just do it this way. Okay, cool. So this is all sort of stubbed out. I'm not doing anything useful at the moment, but yeah. Alright, so now where were we again? Yeah. Okay. So okay, so let's return to our tests. Embedder. Yeah, transformer. Cool. Then batch. Yeah, actually, let's go. That's silly. Let's go. Batch. Let's just list, I guess. Okay, and then dots. Yeah, well, that's fair enough. That is an issue. I guess I can look for a quiet keyboard, or I wonder whether there's a way to filter that. That's something I'll look into. But yeah. Is a language to LLVM and using CLang to compile an executable considered a compiler? I mean, I guess it's, this sort of like definitional thing, there's seldom deep implications for whether you label it that way or this other way. So, yeah, I think the definition of compilation and transpilation, etc., could be kind of flexible. Okay, so yeah, this is what we wanted to do here. Yeah, that's right. So check that the outputs make sense for the number of documents in the batch. So what do we have in our output class? I think the leading dimension there needs to be, so assert embeddings shape 0 equals excellent batch. Then check that the outputs make sense for the number of tokens in the docs in the batch. So let's see here. Oh yeah, actually embedding starts okay, so okay, so I've got embedding starts encoding. Right. Then so this is where we need our word alignment thing. So it would be something like embedding IDs I dot word max, I guess. So just and yeah, this is not something that we really care about. Let's remove that one. Okay. Oh, actually, we can say does not equal. Okay. Or specifically equal to 1. Now, So what did I skip? Oh, I didn't include any parameters. Okay, so now test split and yeah. Okay. Scratch. Where are we here? Pipeline. So yeah, I think that's okay. Let's create a bit of blah box. Yeah. Okay. See, what did we do here? These, then we went like that. Yeah, input IDs, that's what we're going to do. Well, let's hope that it doesn't need that. Okay. Base model output with pooling and cross attentions. Alright, let's see what this object is. So okay, I'm going to move the last hidden state. Okay. Okay, so this is a test. Yeah, so we should expect it to be one less. Okay, encodings. Do we actually have the bidding encoding? Yeah. Sweet. All right. Yeah, so we want, yeah, let's see what happens if we have an empty string. Yeah, so this was one entry, so it's a batch of two. Then we want a test which is just one entry. Okay, so that should be fine. Right, so that's fine. What shape do we end up with when we've got no documents? Wait, that actually doesn't make much sense. So when you give transformers a batch that's empty, says no documents in the batch, it returns you back a single entry with just a BOS and EOS markers, which is not what I would do. But alrighty then. Okay. What to do about that? And that'll be a pain in the ass later. Alright. Must be a way to exfile particular entries in this. I don't remember how to do it though. Let me look it up. Yeah, so create a PyTester param. Cool. Okay. So we say PyTest.param and code that. And then we can go marks. So let's see if that works. Yay. Okay, sweet. Okay. Cool. All right. So this is progress. Yesterday I was saying that, when I'm doing these things and sort of scratching out a new design, I like to alternate between this sort of top-down process where I'm sketching out all of the pieces and getting an overview that fits together, and this sort of bottom-up process where I start to put concrete pieces together and get something running, get something tested, etc. So it's good to have the first concrete little bit done, or at least sort of sketched out. I mean, there's still a lot more to do with this, and things that are just sort of stubbed out in various ways. But it's good to have that piece sort of looked at and running. So the next thing to do would be to start moving up the stack with this. So we can then test the pipeline, because if we can build an embedded, and we already have the spaCy tokenizer, then we can construct the pipeline class. So yeah, let's start doing that. Just a picture. Alright, let's make only one Gert embedded, because I don't want to reload it all the time for this. So okay. Let's see that pipeline. Cool. So yeah, that's fine. Go do that, and then we want tokenizer. So this is like a vocab. Actually, it's probably not the smartest way to do it. Let's do it this way. So it's fixture. Yep. Okay. Okay. What's going wrong here? Ah, okay, so we'll scratch. Cool. Okay, so right. Okay. Well, this is just annoying as a separate test at that point, so I'll just put it here. Okay. So that unit's an empty pipeline. Okay, so okay. Yep, that's right. I would have thought it was weights, but anyway. Okay. So who knows whether this actually does things. Okay. All right, so I'll wrap this up as a short one there. But yeah, the next bits are pretty, straightforward. Just stubbing this out a little bit more, and then yeah, from there we should have something that we can actually test, and you know, in particular, test this business of building the model in pieces and building like a single computational graph for a bunch of components. And then we want to move on to actually, playing with the optimization stuff for it. In theory, we should be able to actually get a test running for, for a legit pipeline in some way, but I don't really want to implement realistic models at this point. So I think I'll still leave it as just, these interface tests without going into actually testing the training technologies and stuff. Assuming all of that goes well, the next step after that will be to switch back to spaCy. So all right, so that's the overview of next steps. Okay, cool. All right. So yeah, I'll leave that there. I think that's a good set of notes for tomorrow. So yeah, thanks. I'm not sure what time I'll be on tomorrow, and I'll work harder at getting the audio. I appreciate the feedback on that. Especially, yeah, I totally see the point with the keyboard. There must be, I can't be the only person who's dealt with this. So, and this isn't even an especially loud keyboard as far as keyboards go. So, I'll look into good solutions for that. Yeah, thanks.